A lot of students, they ask about annuity, what is the present value table, what is the future value table. This video I'm going to discuss about the future value, present value, what is annuity. So let's start. So the first question which comes to our mind, what is annuity? So if you ask me, annuity in a simple term, it is a kind of investment that has a regular installment. And you deposit that installment on a regular period. And these installment can be monthly, quarterly, yearly, or fortnightly, whatever. So one of the good example of this annuity is super fund in Australia. So what her and you both deposit amount every month, and then at the end of the 60 years or whenever you get retired, you get that amount back. So superannuation is a good example of annuity. So now how the calculation of the annuity work. So let's say a person A deposit every month, or maybe take every year starting from 0. So let's say this is a 1st Jan and this is a 31st December. So 1 means end of the year 1, 2 means end of the year 2, 3 means end of the year 3, right? For the simplicity, I'll take these as a month, and super is an example, good example, super fund. So I'll take that as a month. It does not matter whether it is a month or year. What matters is the compounding is happening monthly or yearly or quarterly, because that will define your final amount. So let's start. So in the first one, this person A is depositing $100. Let's say $100. I'll take $1. This one, after second period or second month, again $1, and then again $1. And then immediate after he deposited $1, I'm drawing a line here. So I'm looking immediate after this deposit, third deposit, what is the amount I'm going to have or I'm going to get. So if you look at this $1 which I deposited at end of the first year, before that, let me also take R is equal to 6%. So every period will have 6% per month, which is very high, but let's take for the example. And then your periods are 3 months in this scenario. So what is going to happen? This $1 will compounded twice, and this $1 will become 1.06 square, because it is compounded twice. This $1 will compound just once, so this will become 1.06. So this $1 will become 1.06 because it is compounded only once, and this $1 will remain 1. So if you add all these things, so the value you get, we call it future value or the investment value, after this third period is 1 plus 1.06 plus 1.06 whole square. And if you add all these things, what happens? It will become 3.1836. So you can see that if I have deposited $1 every month, after 3 months, my future value or my value of this investment is 3.18. So if I want to do other analysis is like how much I deposit. So total deposit is $3 only, right? And total value we have got 3.18. So if I want to calculate the interest, it is 3.1836 minus 3, which is dollar or 18 cents in 3 months, right? So this is a complete analysis. In the exam they don't want you because there might be a lot of periods, and when you are going to calculate the annuity, it might be 10 years, 15 years. So what we have done, we have brought a simple table. So to simplify this calculation and everything, but this calculation is definitely needed for advanced student and even standard students to understand how the future value of an annuity is defined. But for simplicity, we also have a table, PV table or future value table, sorry, FV table. So for simplicity, we have future value table, which will give the same kind of information what we are looking for. So if you look at the same information where your R was 6% per period, in this case period is month, but here if you look at the table, it will show you period as well as percentage. So you need to make sure that you are looking for a percentage for the given one period. So in this case our period is month, and then we have 3 months, n is equal to 3, so I'll use a different color. So if I go and look at period 3, and then R is 6%, so the intersection point is 3.18. So you can see here this 3.18 is same as your future value, which you have done by a mathematical calculation or algebraically understanding the annuity. But this table will give you direct insight of a future value of a annuity. So this says that your each month you are depositing $1. So if you see the color combination here, this is $1. So if this $1 you are doing for 3 periods, right, your investment value will be 3.18. So this is the how to read this table is also important. So if you have an annuity of $1 and if you're looking for only 3 periods with each period 6%, then your future value of that annuity will be $3.18. So we read like this. Okay. Now the second concept which comes or which is also very important is a present value. So present value table is also very important. Now in the present value table, so let's see what is a present value table. This present value table is also looks like the same as future value table, but the purpose is different. So what is the present value table? Let me explain the same example what we had here. Let me take this example and take it as this investment value, which we call it future value of a annuity. Now the condition of this person B is that 2. I can't do each month installment, so I want same future value. So he wants to pay, this is a condition given by a person B. I want to pay one time and at the same time I want the same future value. So third condition, you can also add it that I will pay in starting. So when you say starting, means at this point in time. So let's say he is paying X dollar at this point and he will not pay any other things up to 3 period, but this X will become, isn't it, in 3 compounding, same interest rate, same period. So X will become X into 1.06 cube, isn't it? Because the compounding will happen 3 times for this X amount, and he wants this value to be equal to this value. So if you calculate X here, it will be 3.1836 divided by 1.06 whole cube. And if you calculate this value, this will come as $2.673. That means this guy here has to deposit $2.673 to get the same future value. So B is making sure that he is depositing just one time at the starting of the period, and he should also get the same future value. So he has to deposit, based on the simple compounding formula here, he has to deposit $2.673. So this 2.673 is called, this is called present value of annuity $1 for R is equal to 6% and N is equal to 3. And if you look at this value in a table, it is exactly the same. If you look at 6% and 3, if you look at the value 2.67, which is exactly the same what we got here. So this is called the present value of the annuity of $1. And this $1, I'll just highlight few things so that you can see what is $1, and R is exactly same, 6%, N is exactly same, N is equal to 3. So these, the only difference is the person A is a guy who is depositing monthly or in regular interval, which is an annuity, and he gets some investment which is 3.1836 in this case, and the person B doesn't want to do regular installment, but he's saying that I'll pay lump sum amount, which is $2.673 he has to deposit at the starting of the period to get the same future value. I hope you would like this video and this will clear your annuity concepts. Let me know if you need more videos.